So we are starting our lesson with this question. In case you've just joined, let's kick off with solving this question here straight away. In case you're not, don't worry. 150 is not the right answer. There's nothing called 330 degrees question mark. Either you say it is 330 or you say I don't know, right? In the exam, you won't write. There won't be any option of a question mark. You know it or you don't know it. Simple, all right? Okay. Let's understand what this question is. Now, last week, I told you that any angle which is sitting outside a triangle, forget about this being a circle, whatever, right? Forget about that for a second. If you have a triangle and there is an angle which is sitting outside the triangle, that's always equal to the two angles opposite to it, which is interior. So this 120 degrees is a combination of this angle, which is angle ABO. So 120 is equal to angle ABO, the stuff inside, and angle AOB, this angle here. And I can write it as AOB, the stuff inside. Now, I told you last time as well that when you have something like this, and they've made a square here, this tells you it is a 90 degrees. They won't write it. And since it is a straight line, the sum of the two angles should be 180 degrees. So this should be 90, which means, and I'll change the color of my pen. This means this angle here is 90 degrees, which means this is 90. So what would be this angle? AOB will be how much? 120 take away 90 is angle AOB, which is 30 degrees. So this bit here that I'm shaded now is 30 degrees. But I am actually after this angle. I told you the concept of reflex angle last. So if an angle is just making full circle, it is 360 degrees. So here, this angle is 30 and a full rotation makes a 360. So what would be this? 360 take away 30 is 330 degrees. Clear? I did not, mind you, I did not talk about the circle being shown, that's being shown here. I did not talk about this terminology of tangent. It does not really matter. It's just there to confuse you. That's about it. So if you apply the basics of geometry well, you should not be worried too much about what's written around it. Obviously, everything has a meaning, but to solve this question, you don't need that. All right, making sense. I need to see a yes from everyone on the chat now, and we will kick off our next topic today. And we are going to learn something called, thank you very much. We're going to learn something called parallel lines, the geometry of parallel lines. Very important, and it is used in trigonometry a lot. right? So before we do trigonometry, we need to understand the geometry of parallel lines. Okay, I will jump straight to the point, right? So when the two lines are parallel, obviously they don't meet at all at any point. In the world of geometry, the two parallel lines or the parallel lines are represented by these arrows. So whenever you see arrows across two lines, that just should tell you that they are parallel lines. Number one. Now, number two. Number two. Whenever another line cuts this parallel line, anyone has any idea what this line is called? And I'm seeing there's some movement in the chat. Without any notice, people will be out. Anyone knows what this is? It's called transversal. Transversal. This line that cuts two parallel lines, or basically a line that just cut any two lines, is called transversal. In our scenario, these two lines are parallel lines. So maybe I will just sort of change the color, represent it in slightly different. So this red line is transversal. Any line that cuts two lines, parallel or non-parallel, is called transversal. Now, once this transversal cuts two lines, it makes a lot of angles. A lot of angles come into play. Let's try to see what angles come into play. Parallel lines. That's the transversal. I'm just making some numbers. So this angle, I'm calling it angle 1. If you're making notes, please do. It is a very important topic. Angle 2. I'm just making there. You can write any numbers anywhere, but if you want to be with me, wherever I'm writing, just writing it down. Keep writing it down the way I'm doing it. Then angle 5, angle 6, angle 7, angle 8. So there are 8 angles that are made when two parallel lines are cut by a transversal. Now today, what we are going to learn is the relationship between these 8 angles, right? So the first, and I'm going to give you a lot of questions based on that. So please make sure you're making notes so that you have to refer it back and forth, right? Because I won't be scrolling up and down, right? Now the first set of angles is called corresponding angles. If I have two parallel lines, so angle 1 and angle 5 are corresponding angles. One angle outside, one angle inside on the same side. So angle 1 is equal to angle 5. So the corresponding angles are equal. So the theorem of geometry says whenever there are two parallel lines, they are cut across by a transversal, the corresponding angles are equal. Similarly, angle 2 and angle 6 are equal as well, corresponding angles. One outside, the other one inside. Similarly, angle 3 and angle 7 are equal, corresponding angles again. And by now you've guessed it, angle 4 and angle 8 are equal. All good? All right, cool. Let's move forward. Now, I'm going to draw something and you're going to tell me which angles are equal. Okay, tell me, angle 1 is equal to? I'm seeing the response. Everyone should be throwing this onto the chat, please. I'm just asking angle 1 is equals to? Only a few, I think one or two of you picked it up right. Angle 1 is not equal to angle 4. And now this is a caution, a word of caution from my end to people who on the chat think they are most intelligent from the others. They were also wrong, okay? So please listen to me and don't act over smart on chat, right? You're annoying me now, all right? Just listen to what I'm saying. That's about it. They are not equal, but hang on. I just told you that they are corresponding angles, but you missed the key point. Look at the line. Is there a difference between the two that you can see? Did I draw an arrow here? No. They are not parallel, my dear students. So if the lines are not parallel, this geometry does not fit in at all. No angles are equal, period. You're getting my point? 99%, and that's what I saw here. 99% banged it for. Listen to me very carefully. If you're doing this, that means you're not switched on at the moment. You're still drowsing. You're still sleeping. Tell your parents to get you a glass of milk, a Milo, to wake you up. Now, moving on. Next one. So angle 1 is not equals to angle 4. They are not corresponding. They are corresponding, but they're not equal. Okay, cool. Next one. Let's learn angles number 2. Alternate angles. Again, lines need to be parallel. If there are two lines which are parallel, cut by a transversal, then the alternate angles are equal. What are alternate angles? Angle 1 and angle 2. Angle 1 is equal to angle 2. And angle 3 is equal to angle 4. Remember that. Lines need to be parallel. They're called alternate angles. Alternate, yeah, diagonally opposite. Diagonally opposite. Inside only. The next one, co-interior. Co-interior angles. Let's talk about what this is. If the lines are parallel, Arav Kapoor, Sehajpreet Singh, and 4LC Shadow. Last warning. I've called out your names now. Next, you'll be out. You three. All right. Next one. Co-interior angles. Now, co-interior angles are not equal. First of all, let's understand what are co-interior. Angles which are co means together on the same side. Interior means inside. So angle 1 and angle 2. So angle 1 plus angle 2 plus angle 2 are 180 degrees. So the theorem says co-interior angles are supplementary. Supplementary means they add up to 180 degrees. That's what it means. Co-interior angles are supplementary. Similarly, angle 3 and angle 4 are also combined, addition would make it 180 degrees. Everyone clear so far? All right. Let's try to do a question and see where you land. Okay, I'm just showing something here now. Time to do some questions. Two lines are parallel. Always look for this arrow, my dear students. Always look for these arrows. All the stuff that I told you above fit if the lines are parallel. The topic that we are doing today is called parallel lines. So the lines have to be parallel. Okay. Two parallel lines are cut by a transversal. 110 degrees is the angle. This is x degrees. And this is y degrees. Can you find me x and y, please? Give x equals 2, comma, y equals 2. Kathy, what is 70? I don't understand. What is 110 and 70? Give me x equals 2, y equals 2. All right. Last week, I told you something that if you have this kind of a scenario, then this angle is equal to this angle. Angle 1 is equal to angle 2. What are they called? They're called vertically opposite angles. So if you look here, I'll change maybe the color of my. If you look here, that's exactly the same scenario. X is in a vertical opposite relationship with 110 degrees. So X is 110 degrees. So now this is 110. And co-interior angles, which means X plus Y will make it 180 degrees. Co-interior angles are supplementary. They're on the same side. I know my x is 110 degrees. So angle y is 70 degrees. I've just given it to you, Harihara. Okay, let's do it now. How do you find y? Come on. I just told you that they are co-interior. X and y are co-interior. And I gave you a theorem here. Co-interior angles are supplementary. They add up to 180. So I said x plus y is 180, and we just found x to be 110. So 110 take away 110. 180 take away 110 is 70. Finish. All right, let's go to the next question. 68 degrees, A degrees, B degrees. Can you find me A and B? Quick. Yes. So A is 112 degrees and B is 68 degrees. How? This angle here, I'll change the color. The angles in the red are corresponding angles. So that means angle B is equal to 68 degrees. So I found B now. Here. Now A and B are like this. This is 68 degrees. And I just need to find A. Angle on the straight line are 180. So you say A degrees plus 68 degrees equals to 180 degrees. So A equals to 112 degrees. Easy peasy. Everyone, clear? So far, so good. All right, let's move forward. All right, I'm going to paste something on the screen now and see where you land. I want you to find this angle for me, angle ABC. Go for it. I've seen a lot of you said 120, a few of you saying 60, someone saying 80. All right, let's understand what this is. Now, the challenge here is that I haven't told you anything that, how do you find an angle between the two parallel lines? So what you need to do is, you need to just sort of add another parallel line. And now it's easy, right? So this big angle is a combination of this angle and this angle. So let's deal with this angle first. This angle. 50, 50. So this must be 50. Why? Alternate angles. Similarly, if this is 70, this will be 70 as well. And a combined angle will be 70 degrees plus 50 degrees equals to 120 degrees. Is everyone clear? How do we deal with these kind of scenarios? All right, cool. Let's move forward. What students still coming in? Okay, let's try one more. Let's try this and I'll take another snippy. All right, let's try this one, please. Give me the measurement of Z and T. Go for it. I have how many students today? Got 41. Yes, they are both 58 degrees. You're right. Why? Because can someone tell me on the chat now? Please type on the chat what relationship Z has with 58 degrees here. What relationship is that? Any relationship by any chance? Alternate. Did you say alternate? I don't know how it is 58. You told me both are 58. Is there any relationship between this and this? They are not corresponding. All of you told me 58, 58, including people who think themselves to be, pro here. No. And for God's sake, look at the angle. That's an obtuse angle. How on earth can it be 58? It should be over 90. So, number one, there is no relationship between Z and 58 degrees. I did not tell you, they're not corresponding. Yes, you didn't realize, and that's what happens in the exam. Right? I have no relationship with Z and 58 here. Nothing. So what do? I do have a relationship here. This angle, let me call it as angle 1. Now, angle 1, this is certainly 58 degrees. Corresponding angles. Now, this is 180, take away 58 degrees. So there's no point you are jumping the gun looking at the question. Just jumping the gun. And exams penalize for you, this one. Penalize you to do this one. Now, okay, is there, so whatever that is now, calculate, okay? Now, is there a relationship between this and T? Is there a relationship? Are they equal, not equal? Think about it before you tell me. And if yes, what is the relation? Why they are equal? Both are 58. I'm asking you why they are equal. Yes, they are. Good job. They are vertically opposite angles. Opposite angles. So next time, please take your time before you answer my question. Okay? Let's try one more. Take another snippy. Okay. Here you go. Give me X, please. Give me X, please. Take your time. There's nothing called question mark. If you don't know, say I don't know. Have guts to write the right answer or incorrect answer. That's okay. Take your time. I'm just giving you another sort of a minute. Think about it, guys. Come on. Think about it. Just don't give up. It's all about thinking, applying. That's about it, right? Okay, let's give it a go. Yeah, 118 looks like. Let's give it a go. Challenge. We do here. Very important symbols are these symbols. They are parallel lines. And students, this line, the red line, is, and if I just extend it, and I extend this parallel, this line is a transversal. You're getting my point? So this angle must be equal to this angle. Why? Can you tell me why? Why? The arrow sign is fine, but what are these angles? If I have these two parallel lines and I've got this one like, yeah, so this angle and this angle, what are these? Vertically opposite angles. Are they vertically opposite angles? Seriously? Alternate. Alternate angle. 30. So this will be 38 degrees. They are 38 degrees. So what would be this angle? The sum of the triangle, I'll come to you, don't worry, Aaron. The sum of the angles of the triangle is 180 degrees. So this angle is 180 degrees. Take away 38 plus 24, which is 118. So this angle here, which I'm now shading in red, is 118. So what is x? X is equals to 180. Why did I say that x is 118? Can someone tell me why they are 118? Why x is 118? The moment I found this and I said, x is 180. Why? Vertically opposite angles. Exactly. Vertically opposite angles. Now, there is a very thin line. I mean, it is slightly confusing, and it used to confuse me as well when I was your age. Vertically opposite and alternate angles. Vertically opposite angles have nothing to do with parallel lines. Nothing to do with parallel. It simply tells me whenever there are two lines that cross each other, they make four angles. One, two, I change the color, three, four. Opposite angles are equal. They call it vertically opposite angles. You add the word vertically, but opposite angles are equal. So angle 1 is equal to angle 2, angle 3 equals to angle 4. They are vertically opposite angles. And alternate angles are always with respect to parallel lines. So I have to call it out. When the two lines are parallel and there is a transversal, then the angles inside opposite to each other are, so 1, 2, 3, 4. 1 equals to 2, 3 equals to 4 here as well. It's a big difference, yes. Okay, cool. Let's keep the ball rolling. Let's keep the ball rolling. Just trying to think which one should be the best way to give it to you. All right, let's do this one. That looks good. Zoom it a bit more, and I take another snippet. There you go. Take your time before you answer. Give me U, V, and W. Go for it. Try. 110, 50, and 50. That's what people say. All right, let's give it a go. Let's give it a go. This, okay, the color may be red. This line and this line are parallel. This angle and this angle are what? They are co-interior angles. Co-interior angles. So that means u degrees plus 70 degrees should make it as 180 degrees. So what is u? U is 180, take away 70 is 110 degrees. So this is 110 degrees. Sorted. First one sorted. Next one. This angle and this angle are again co-interior. So can I say W degrees plus 130 degrees equals to 180 degrees? So W degrees is 50 degrees. So this is 50. And then W and V. What's the relationship between V and W? They are equal. Why they are equal? They are Alternate angles. Yes. Good. Any dramas here? Anyone? Okay. All right. Uh, that was a gist, of uh, the geometry of parallel lines, right? We can go on and on and on. But I also wanted to touch upon, a very important uh, topic is polygons, quadrilaterals and polygons. So I'll just give you a brief about that as well, so that basic things, that could be handy when it comes to exams. So let's talk about quadrilaterals. Can anyone tell me what are quadrilaterals? What are quadrilaterals? Quadrilaterals. Quadrilaterals are figures that have four sides. Exactly. Give me a few examples of quadrilaterals, please. It can be regular, irregular. Yeah, you're right. Yeah. Square, rectangle, rhombus, parallelogram. They're all quadrilaterals. Good. What is the, so we've got four sides, right? What is the figure with three sides called? Triangles. Good. What is the figure with sides five? Five sides. Five sides. Pentagon. Correct. What is the figure with six sides is called? Hexagon. Good job. Hexagon. What is the figure with seven sides is called? I hope you're not Googling it, right? Heptagon. Good. What is the figure with eight sides called? Octagon. Good job. Nine sides. It's called nona, not no, nonagon. Nonagon. There's nothing on nonagon. Nonagon. 10 sides. Deca, not deco. Decagon. Decagon. 11 sides. Tell me 11 sides. Undecagon. 12 sides. Good job. Loving it. All right. So all of these are combined called polygons. They're all polygons, right? There's one combined name that's called polygons, right? Now, all of them have have different measure of the sum of the angles. So triangle is like 180 degrees if you measure their interior angles, right? And then quadrilateral has like 360 degrees, and they keep moving, right? They keep moving. Now, what happens is that you can only remember all of these, the sum of all their interior angles to a point. So, but then there is a formula where you can get the sum of the interior angles of any polygon. And the formula is that's called the angle sum. The angle sum formula. The angle sum formula tells me n take away 2 times 180 degrees will always be the sum of any interior angles across. All good? So let's say, for example, if I have triangle. So for triangle, the n is basically the number of sides. So triangles, n is 3. Let's plug it in. 3 take away 2 times 180 degrees. So which means 180 because this boils down to 1. And then you can input any value of the side and you get the sum of the sides. Sum of all the interior angles. Okay, few important things. Types of quadrilaterals. If we just talk about types of quadrilaterals. So the first one is parallelogram. I write it like this: two parallel lines, gram and GM. So parallelogram is that four-sided figure where the opposite sides are parallel. You see how geometry works here, right? I have a single arrow and single arrow. That means these two lines are parallel. Whereas the double arrow tells me that these two lines. So this is a parallelogram. If I draw a diagonal across the board, then the diagonals cut equally inside. That's parallelogram. Vertically opposite angles are equal. Yes, you're right. So they are all equal. Good. Now, the next one's called rhombus. Rhombus is a parallelogram which has all four sides equal. Something like this. I also draw this along with it. When you see these four cuts across the four lines, that means they are equal. Right? Now, the beauty of rhombus is that when you draw the diagonals inside, they cut at 90 degrees. They are all 90 degrees. Whereas in parallelogram, they are not. So rhombus is a parallelogram with all four sides equal. That is what the whole point is. Now, let's talk about rectangle. Rectangle is also a parallelogram, but the angles of the rectangle are 90 degrees. So this parallelogram, it's sort of it's given a nudge, and it becomes like this. It becomes like this. So a parallelogram, if you sort of give it a nudge here, it becomes straighter. Again, the sides are parallel. The sides are parallel. But the angles inside are not 90 degree. However, having said that, they are equal from a vertical opposite angle geometry. So rectangle is a parallelogram as well. Last one, a square. A square is a rhombus. Is a rhombus. Square is a rhombus with angles 90 degree. Finish. So what was rhombus? Rhombus was all four sides are equal. So in rhombus, I have drawn something like this. I draw it in square as well. So rhombus is a square, a square is a rhombus and is also a parallelogram. Getting my point? And the property of rhombus, you see here, everything was 90 degrees, same as square. That is why square is a rhombus and hence a parallelogram. Parallelogram is like this is the father figure, right? You know, you've got variations under it. Square is a parallelogram, rectangle is a parallelogram, rhombus is a parallelogram. Square is a rhombus, rhombus is not a square. Okay? Make sure. This is very confusing, right? But if you understand it well, you don't go wrong. And then there are a few more sort of shapes that you should know, but they're very important. The first one is trapezium. Very important figure used in geometry like hell. It is a quadrilateral with two sides parallel and two non-parallel. So these sides are non-parallel, whereas this side are parallel. That's called trapezium. Very, very important. And the last one is the kite. Kite is something like this. So the property of kite is the adjacent sides are equal. The adjacent sides are equal. The diagonal, if I draw a diagonal of kite, they cut at 90 degrees across each other. And the shorter diagonal, another property, the shorter diagonal, when it is cut across, is divided into two equal parts, not the longer diagonal. So they are special quadrilaterals, kite and trapezium. All right, cool. With that in mind, I give you one last question before we go, right? Before we finish this off. Okay. I'm going to take a snippet of this one and see. All right, let's do this. Can you find A for me? Give me A. Last question of the day. Give me A. There's nothing called or here. Give me one answer. That just tells me how you are, how uh, concentrated you were when I was teaching this. There's nothing called a question mark. There's nothing called is it. Either you say I know it or you say I don't know it, right? Is it? No, it is not. It is not 210 degrees. All of you are incorrect. I just saw the right answer. 240 degrees is the right answer. Good job, Nirvi. Good job. Was it Kartiki? Good job. Yeah, cool. 240. Why 240? Is just count the number of sides. 1, 2, 3, 4, 5, 6. There's 6 sides, and I gave you the formula to find the sum of the 6 sides. So that was angle sum was n minus 2 times 180 degrees. N is 6. 6 minus 2 times 180 degrees, and that will be 720 degrees. And now you add all of them up. This one is a 90 because it's not very clear. So 90 plus 115 plus 100 plus 135 plus 40 plus A equals to 720. Find A. Finish. A is 240 degrees. Good job. I think a couple of you were able to do it. All right, with that in mind, with that question, we end our lesson today. We've done all of what is required from your exam standpoint, basic geometry, and where we've gone over polygons, etc. Next week, the plan is to kick off trigonometry. All right. So if you're interested, please come and join and tell your other friends as well if they're interested in learning trigonometry. Have a good one. Bye.